Here we go. We won't do all of the examples that I planned to do today, but those people away. But this comes from page 172 in the textbook. These are just a few other friction examples. So if you guys could follow along, you have the sheet. You just need to jot down the answer. So example number 8 says, a lawnmower of mass 12 kilograms is being pushed by a force of 150 newtons horizontally and 40 newtons down. So in other words, if I could just quickly draw a free body diagram here, they've already broken it into components for you, right? They're pushing down like this, right? So we've got 150 newtons sideways, and we've got 40 newtons down. So they've broken it into the components for you. Jory, you need to put the phone away, please.
What's this total?
Okay. The mass of the lawnmower is 12 kilos. If the kinetic coefficient of friction between the wheels and grass is 0.9, that's pretty high. Find the force of friction acting on the lawnmower. So my mu value is 0.9. The force of friction, I'm solving for FF. Now, we know that mu equals FF over Fn. Do I know my normal force yet? No, I do not. So before I can do the final step, mu equals FF over Fn, I'm going to need my normal force. The normal force is usually equal to the weight force, but in this case here, because I'm actually pushing down on the lawnmower, I'm actually increasing the weight, aren't I? Okay, so I think the first step we should do is find the weight force. So let's go FW is equal to mg. So that's 12 times 9.8. Times 9.8, or 117.6 newtons. And I'm just going to quickly draw another free body diagram here, just a small one. We've got our weight force down. I'll maybe do it like this. We've also got our vertical force down, and we've got the normal force up. So in other words, the normal force has to be balanced by the weight force and the vertical component. So in other words here, my normal force is equal to my weight force plus the vertical component. So in this particular case, it's 117.6, and I have to add the 40 additional newtons that this poor person is pushing down on as well. So I get 157.6 newtons of normal force. Now, hold on here. Does it say anything about acceleration? The question doesn't say anything about acceleration, right? Jory, when you cut your grass, do you start at one side of the lawn and do you accelerate to the other end? Or do you tend to walk at the constant speed? I tend to walk at a constant speed. So, do you? Yeah? If you're pushing at a constant speed, shouldn't the net force be 0? Which would mean that if I'm pushing sideways at 150 newtons, shouldn't the friction force be 150 newtons? Shouldn't it be? Like, if I'm pushing sideways with 150 newtons, shouldn't friction be in the opposite direction with 150 newtons? Wouldn't that just be the answer? And I think in the real world, the answer to that is yes. However, this textbook, being a little bit off here, has actually, that's not true. Because if I do this, if I go mu equals FF over Fn, my 0.9 is my mu. Solve for friction force, put a normal force of 157.6 down there, and you're again going to get a friction force of that value at 40 times by 0.9. You get 141.8 newtons of friction. Okay, I think the textbook shows 142. They do it to sig figs. What does this mean? Well, it means, and it didn't ask me this in the question, but since the FH is bigger than the friction force, what does that mean? It means that there's a net force, right? In fact, the net force is going to be 150 minus that 141.8. there's a net force of 8.2 newtons, which means the guy's actually accelerating like Zach wants to with his lawnmower.
Yeah, but like maybe you're stopped to start and then you just gotta
Well, that's true.
speed up.
True enough, I suppose. Maybe that's just initial, perhaps, right? And in fact, I think, if I'm not mistaken, what does example number 9 ask? Example number 9 actually asks us for the acceleration of the lawnmower. So what would be the first step of finding the acceleration of the lawnmower? It'd be this thing right here, wouldn't it? I'll maybe just rewrite it. Okay, to find the acceleration of the lawnmower, we're going to say F net is equal to horizontal component plus friction. The horizontal component was 150. I subtract that 141.8. Is that what it was? Did I get that right? 141.8. So I get a net force of about 8.2 newtons. And now I'm going to say F net is equal to MA. 8.2 is equal to my mass. My mass of my lawnmower was 12, I think. Yes, 12 kilograms. Find the acceleration. 8.2 divided by 12, 0.7 meters per second squared. Okay, that's pretty easy.
Question.
Yep.
What do you want us doing for rounding?
I like to go just one more decimal place than what's given. I'm just not going to worry about it. It's just not important to me.
Other question was like,
Do you want to try example number 10 on your own? Give it a whirl. Let's have a quick read. We'll see if I'll see if I can set something.
this, I can put it in school.
Hey,
What are we doing after this?
let me finish.
She's not done yet.
Two people are pushing horizontally in a crate of mass 50 kilograms. One person is pushing from the right with a force of 50. The other person is pushing from the left with a force of 80. So they're really not working very well together. The coefficient of kinetic friction is 0.3. Find the acceleration. Okay. Oh yeah, you guys can do this, right?
Yeah.
I think you can do this. I'll draw a little free body diagram here to get you started. Pushing from the right. So the 50 newtons is from the right. So this is actually 50 newtons to the left. So technically negative. The 80 newtons is from the left. Okay, you are asked to find the acceleration. I don't think that's more than 2 or 3 steps. There is going to be friction here as well, a friction force, and I haven't drawn it. Which way would the friction force be? If the 80 is to the right, the 50 is to the left, clearly if there was no friction, the object would be moving to the right, so therefore friction is which way? Friction is, friction is this way as well, right? So you need to find the acceleration, you're going to have to first find the net force. Did it seem like your answer doesn't quite make sense? Do you have a nagging feeling that something's wrong?
Yeah.
That's good, because there is something wrong. But that nagging feeling is good, because your intuition is telling you that there's something wrong here. Let's talk about this. Two people are pushing horizontally at a crate of mass 50 kilograms. One person pushing from the right with a force of 50. That's this one right here. We've got the 80 this way, right? The coefficient of kinetic friction is 0.3. I heard Zach say, whoa, the friction force is really big. Let's just work that out. First of all, I guess I got to do my weight force, right? By the way, if at any time you're really stumped, always put the weight force down. Quite often there's a mark associated with that, right? So this is going to be 50 times 9.8, which is 49, I believe, right?
Wait.
Oh, sorry, 490. That's what I meant. So the weight force is 490. Then you're going to go mu equals FF over Fn. So 0.3 is equal to friction force over 490. So you get a friction force of 147. Okay, so now what I really need to do is come up with a net force, right? My net force is, how about I call them F1 plus F2 plus FF. Okay, and the F1 I'll make 80, positive 80 to the right. F2 is going to be minus 50, right? And the friction force has to be in the same direction that the movement would be if there was no friction, which we know to be to the right. The 80 is bigger than the 50. So then I'm going to subtract 147. and you get a net force of how much? Negative 117. Is that how you got when you went F net equals MA? Let's just go through this and then we'll talk about it here. So we got minus 117, 50 kilograms, A equals, let me see here, divided by 50, you get minus 2.34. Minus 2.34. This crate is accelerating to the left at minus 2.34 meters per second squared. Put on your real world filter hat and say, whoa, is this what's going to happen here? If someone pushes with 80 to the right, if someone pushes with 50 backwards, is the crate going to go to the left?
No.
It's not going to go to the left, is it? What's it going to do?
30 newtons to the right.
It's not going to do anything. It's going to sit there. There is too much friction. Very good, Cody. Okay? There is too much friction. In fact, this is probably a bit of a dangerous thing to do because this leads you to this, right? Maybe what we should have had was, maybe I should have said F net apply. Maybe I should have said that the total applied force is 80 minus 50 or 30 newtons, right? And then realize that my friction force is actually greater than my net applied force. It's dead. Okay. Therefore, what happens? No movement. Okay? And in fact, is the friction force going to actually be 147? No, in fact, friction is much like a teenager, only does what it has to. Little joke there. Okay? It would actually be only 30 newtons, right? If friction was more than 30 newtons, if it was the 147, then it indeed would move backwards. And that's not how things operate. Like if I just push lightly against this, does the friction send it flying that way? Of course not. Okay? It only pushes as hard as it needs to. So in this particular case, because the net applied force is less than the friction, the thing does move. Does that make sense, Taylor? Does that nagging feeling, has it gone away now?
No.
No? It's right now. That's right. Okay. I will leave the last two for you. If you want to do them as problems, I can give you the answer tomorrow. They're actually in the textbook if you want. Okay? The actual answers. I will now, example 11 and 12, I guess they are. I'll now give you some questions to do. Page 188. And there's several here, 39 to 48. Enjoy. Oh, and for those of you who did manage to come to class today, I'll be giving you all a $20 bill and the answers to the exam.